Hello. Now that we have seen how to find the domain of a function, what I'm going to show you now is different ways in which we can write the domain of a function. So far, we've been writing the domain using set notation. Right? I'm going to show you how to write the domain of a function using interval notation. So let's do it here with an example. Before I dive into interval notation, though, I'm going to show you how to represent a set of numbers using just the real line. So if you remember from the first set of lectures where we were talking about sets and the real numbers, you can represent the set of real numbers by the real number line. And this is the real number line because we know that it doesn't matter what number I pick in here, right? So it doesn't matter where I put some of those vertical lines. I know that any of those numbers is a real number, right? So there are no gaps in this line. Okay? But again, I talked about that in the first set of lecture videos. So let's say that someone asks us to represent all real numbers greater than or equal to 0 using a number line. The way you do that is, okay, so I want to represent all numbers greater than or equal to 0. Since I want to include 0, I make a solid dot on the number line. And then I want all real numbers greater than or equal to 0, so I'm going to move towards the right. Oops. So I'm going to draw a line that goes towards the right with an arrow. And anytime I draw an arrow, that's just representing the fact that this line keeps going on forever. So that's how you would use a number line to represent the set of real numbers greater than or equal to 0. Now, suppose I now want to represent all real numbers less than 1 using, again, a number line. So you do the same thing. You draw the real numbers, or the real number line, sorry. And then, just as before, so since we want all real numbers less than 1, right? Now, it's not less than or equal to 1. It is less than 1, so it's different. Right? So compare less than to greater than or equal to. Right? How do you denote the fact that you're not including 1 on a number line? Instead of doing a filled-in dot, you use an open dot like this. And since we want all numbers less than 1, then I just draw the arrow going towards the numbers less than 1. And this is something that you probably saw, around 7th or 8th grade, or maybe even before that. But it's useful to remember because we can represent these sets using a similar sort of idea. So the way we do it is like this. Suppose now that I want to represent the same sets, but using intervals. So represent each set using intervals. So for the first one, I'm looking for the set of real numbers greater than or equal to 0. Right? And just as before, since we're including 0, we want to use a specific symbol for that. Right? Since we're including 0, use a bracket symbol. Right? And then we're moving towards the right, because we're looking for all real numbers greater than or equal to 0. So you put a comma, and then since we want all numbers greater than or equal to 0, I can't really put another number here because if I do that, that means that I'm only looking for numbers between 0 and, for example, in this case, 7, including 7. Okay. So since I want all real numbers greater than 0, what you do is that you write the infinity symbol. And anytime you write the infinity symbol, you want to use a parentheses. So now that I've introduced these two symbols, bracket and parentheses, let me just really quickly write what they mean. So bracket means include, and it doesn't matter whether it's the left bracket or the right bracket, right? So either this or this means include that number. And then using parentheses means exclude. So with infinity, since it's not actually a number, it's just a concept, right? So infinity is just a symbol that explains a behavior. In this case, the behavior of choosing numbers that are getting larger and larger and larger, right? So that's why we cannot actually use brackets with infinity because it doesn't make sense. Infinity is not a number. Okay. Now, let's do the other one. So this was the first one. Now for the second one, we're looking for all real numbers less than 1, but not including 1. Now, since we're looking for all numbers less than 1, so we're towards the left of 1, we're going to use the symbol negative infinity. And again, I need to use the symbol infinity because I want to include all numbers less than 1. If I write a fixed number here, then I'm stopping, right? But I want to include all of them. And again, you encompass that behavior using the infinity symbol. And then I move from negative infinity towards the right, and I want to stop at 1, but I don't want to include it, so I use the parentheses symbol. And these here are what we call intervals. Right? So anytime you see something like this, that's an interval. And you can always imagine an interval in a number line. That's another reason why I present it like this, because I like to think of number lines whenever I'm thinking about intervals.